So in this lesson, this is technically part of the quadratic unit, but we waited until the test portion of it is done so that you can kind of refocus on reviewing, the difference between linear, quadratic, and exponential functions. And when we can see that one of these will be the best to model a set of data, whatever sort of data. So we're going to look at different kinds of tables, and we're going to decide what kind of function is in that table. Is it linear? Is it exponential? Or is it quadratic? So what we're going to be looking at is going to require us to know some new vocabulary. So there's two things we need to know that we're going to focus on. We need to know first difference and second difference. And this is going to make more sense as we start looking at different tables. So first, let's review linear functions. Linear functions will form a straight line on a graph, and we have slope-intercept form as being one of the main forms of the function, y equals mx plus b. In exponential, it makes a function that rises or falls and then has this asymptote line that it will never reach. And this was we'll change to f of x. This is where we had our constant ratio to the power of x. We could also see that as initial value times constant ratio to the power of x. And in quadratic, it forms a parabola on the graph, and one of the main forms of the quadratic function is in vertex form. So these are kind of the more like what we would use most often type forms, okay? So let's look now at a table, and we're going to figure out what kind of a function it is based off of the table and the values. So I'm just going to sketch one out quickly. And you can follow along on the note taker with this, the handout, or recreate it in your notebook, which would be a great idea. I would at least take notes on this and keep it in your notebook if that's what you choose to do. So we have an x value, we have a y value, and then we're going to look at the first differences. I guess we should put an S on these two. Okay, so let's say we have these values here. So what we're looking at is the differences between the consecutive y values. The differences between these consecutive y values, that's going to be the first difference. So as we can see here, the difference between -1, well actually we always use the second one first. So you want to go this one minus this one minus this one. So 1 minus -1 gives us 2. 3 minus 1 is 2. 5 minus 3 is 2, and so on. So then we would go, and actually we'd probably want to start it down 1. We should have started these down 1, but that's what it'll show in the paper. So when you have a constant rate, okay, so you've subtracted and you have a constant rate, that is a linear function. And think about it this way as well. This would be like what we would do when finding slope. So the slope of our function would be positive 2 because each one is increasing or decreasing by 1, and it's going up by 2 each time. Okay, so that's an example of a linear function. We should add, so this is the first difference. Between consecutive y values is a constant rate. Not to be confused with ratio, okay? It's a constant rate. So it's just constant. Whoops, got the S. Okay, let's do another one. So we're going to look now at first difference and second difference. So if you see that there's a constant value in the first difference, these numbers are the same when you subtract, that's always going to be linear, okay? When you don't see a constant rate or change in the first difference, you're going to look for the second difference. So I'm going to show you how to do that. So we're going to use 0, 1, 2, 3, 4. And then okay, so we're looking at the differences between the consecutive y values. So we do 9 minus 3, 6. 19 minus 9, 10. 33 minus 19 is 14. And 51 minus 33 is 18. So we can see there's no pattern here. There's no constant change here. Okay, so we take it now, we look at the second difference. So we're going to do 10 minus 6, 14 minus 4, and you can, or 10, excuse me, you can see now that our second difference is 4. These are all now the same, okay? When you find a constant in the second difference, that is a quadratic function. Second difference between, I don't know if you can see all that. I'm writing it off to the side. You can't see it. Basically what we're saying is the second difference of the consecutive y values is constant. I'm struggling with that word today. So it's the same, okay? Let's do one more type because we need to know what it looks like then when it's an exponential. That's coming up next, obviously. So we'll do another table. Okay. So we'll look here at the first difference, 2 minus 1 4 minus 2, 8 minus 4, and 16 minus 8. Let's try the second difference. 2 minus 1, 4 minus 2, 8 minus 4. Still no constant in the first or second difference. So now let's look at the ratio, because we can see these numbers are related. They're all kind of part of the same fact family. We're going to look at the ratio of consecutive y values. So instead of it being just the difference, we're going to look at the ratio of consecutive y values. So here's the y values, and actually we can even look this way. But let's look at this. We're going to do 2, hold on, 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. And 16 divided by 8 is 2. So here's where we see a constant ratio. And that means it is an exponential. And remember, that's what the B value stood for, was constant ratio. So this table is an exponential function. So that's how you determine which kind of function it is. If you find the constant rate in the first difference, it's linear. If you find it in the second difference, it's quadratic. And if you don't see it in the first or second, but your ratio of y values is constant, it is exponential. So you're going to practice now on the back side with these tables, filling them in and identifying which type it is, and then you're done.